we're solving a exponential equation with fractional base. All right, fractional bases. Now this very first step right here is pretty thinly veiled camouflage. Both numerator and denominator share a factor 2, so we can reduce the fraction to 81 over 16. And again, we're trying to solve for x right here. All right, now one very important observation right here is that 81 raised to the minus 1/4 is equal to 2/3. Now, that's based on the property that if you have a base raised to a negative exponent, and this follows really quickly just from the definition of exponentiation, b raised to the minus m is equal to 1 over b raised to the m. Okay, again, a fairly well-known result just from exponents. So you have b to the m, 1 over b to the m. Now, notice though that the 2/3 here would just be the same thing as 1 over 81/16 raised to the positive 1/4. Okay. You know, the fourth root of 81 is 3. The fourth root of 16 is 2. And so this is equal to 1 over 3 over 2, right? Again, this is just the idea behind the rule about the negative exponents. You don't necessarily have to, I was just showing it in case some of you may have forgotten. But 1 over 3/2 is the 2/3 that you see right here. Now that turns out to be very crucial because we can just substitute this right here. Okay, in other words, 2/3 is present right here at the original problem. We can just substitute this in, and that's what I did on the very next line. Okay, I just simply replaced 2/3 with what it's equal to right here. And now we can use the laws of exponents that says you can multiply exponents in this context, meaning, let me just write this off to the side. If you have b to the m, b to the m raised to the n, again, m copies, n copies of m copies is m minus n copies, though this is b to the m n, okay, the product. Okay, and notice that's all that happened right here. I simply multiplied minus 1/4 against x minus 35 over 4 to get this. You see how things just reversed essentially? Okay, and you get the 35/16 when you multiply minus 1/4 times 30 minus 35 over 4. Now, the cool thing about this is that once you have this going on, the exponential function is 1-to-1, you can actually equate the two exponents. Now you couldn't do that if the function wasn't 1-to-1, but it is. So we can actually equate the exponents since we have the same base. So we actually set we set x equal to 35 over 16 minus x to the 4th. Okay. Now, folks, if we add x to the 4th to both sides, this leads to 5x over 4 equals to 35 over 16. And folks, it's not hard to see from this point. If you get x isolated, that's the same as multiplying through by 4/5, but this would imply that x is equal to 7/4. I left out just a little bit of the work, but x equals 7/4 is the solution here. Okay, so that's it. X equals 7/4 is the solution to the original equation. Now, if you want to, you can run up here and check it yourself. But again, x equals to 7/4 is the rational solution to this exponential equation. Thanks for viewing.